SIGER Data's Precision Machining Digital Intelligent Application Case.
The machine model is UGHAMC 2000, a 4-axis horizontal machining center. The CNC system is FANUC 18IM. The workpieces are large structural housings used in machine tools, heavy machinery, and energy equipment, requiring high stability, precision, and surface quality. Heavy-duty cutting commonly faces the following challenges. Pain 1. Conservative feed strategies. Pain 2. Obvious load fluctuations. Pain 3. Slow manual response. Adaptive feed optimization based on target load. The SIGER AMS system uses spindle power signals and AI algorithms to sense cutting conditions and adjust feed rates in real time. During roughing and heavy material removal, the system compares target load with actual load in real time. Feed increases automatically at low load. Feed decreases near load limits to avoid conservative inefficiency. Cycle time is reduced from 187 seconds to 122 seconds, achieving a 34% overall efficiency gain. Efficiency improvement by operation. Rough machining efficiency increased by 30, semi-finishing efficiency increased by 20, finishing efficiency increased by 10%. When sudden load changes, hard zones, or tool wear occur, overshoot is suppressed and noise is filtered, feed rate is adjusted continuously and smoothly, efficiency improves significantly, while cutting stability and surface quality are maintained, with no chatter marks. Through continuous learning from similar materials and conditions, the system converts tuning experience into reusable parameter models, reducing reliance on operator expertise. System deployment and on-site training are completed within 2 weeks. Operators can get started within 1 hour. The system adapts to various machine tools and machining centers. With one hardware platform, it supports a 4-in-1 solution. Tool monitoring, collision protection, adaptive machining, thermal compensation. Enabling intelligent production lines, choose SIGER data to reduce costs, increase efficiency, and ensure stable production.